Good evening. This is Robert Scribbler, June 11th, 2018. And today what we're going to do is review a report that has been put out by Resource Watch, which is a global monitoring agency that looks at impacts from climate change. And the report that we're going to be looking at is a survey through 4 maps of future ocean health. Now, before we go into the individual maps, I'd just like to say that there are a number of impacts to ocean health from human-caused climate change, and they come from increasing ocean temperature, increasing ocean acidification, and a process that arises from warming oceans that reduces ocean oxygen content both in a biological fashion and also just due to increased heat and also sea level rise. Now, there are a number of additional knock-on impacts to oceans and their ecosystems from these 4 factors, but these 4 factors are the primary or among the primary impacts to ocean health. Now, this particular report doesn't go into ocean anoxia or loss of oxygen in the ocean system per se, although it does provide a broader map of overall ocean health impacts, and this is what we're looking at now. So I'm going to just scan through this here. And so, for example, if you're looking at high impacts, and this is in a survey of impacts in the present day. So what the research has taken into account is marine ecosystems from 1984 to 2014. And this map shows impacts on a low to a high scale, low measured in blue, high measured in yellow. And in the yellow, green, light, and light blue regions, you presently see the highest impacts. So right now we're looking at highest impacts in regions such as the North Atlantic and the Baltic Sea and near Greenland. And this is due to a number of factors, including ocean circulation change, warming ocean surfaces, increasing algae blooms. In the Baltic Ocean, you have a zone of anoxia and also hydrogen sulfide gas in the deep portion of the Baltic Sea, and so that's a major impact. And also the North Atlantic is also one of the most productive zones, so high impacts in that zone is a bit of a warning light. And looking around, we find also high impacts, relatively high impacts in the Pacific, in the North Pacific, and also off the coast of South America, and in some sections off the coast of Africa, as well as through portions of the equator, and near New Zealand and Australia. So this is a composite map. It doesn't drill down to each particular impact, but it does provide a good overall view. What I found more striking in this report, however, is its survey of coral bleaching. And so I've been writing papers on coral bleaching since about 2012, and the research with regards to impacts to corals is pretty grim. So corals suffer from a combination of warming oceans as well as ocean acidification. Now, the warmest regions of the world are at the equator, and so the corals closest to the equator see the greatest impacts earliest from warming. But ocean acidification proceeds from the poles southwards. So what ends up happening is that corals, which are primarily closer to the equator, get hit with warming first, and then as the oceans become more acidic, they get this second wave of impact coming from the higher latitudes to lower latitudes. And so by mid-century, the situation looks really bad for corals under business as usual warming scenarios, or even under scenarios where atmospheric CO2 exceeds much higher than 450 parts per million. So this is a forecast for coral bleaching frequency in 2030. And the map indicates that if you're looking at yellow, that's a 100% or near 100% coral bleaching rate per year. So there's enough stress on corals to cause corals to bleach in the yellow zones every single year. And if you're looking at the blue, it's once every 10 years or less, so in the dark blue. And so here what we see is that by 2030, most of the equatorial region is showing a biannual frequency of coral bleaching events, and that's rather severe. But if you flip over to 2050, and this is under current trends, you find that the stresses to corals are such that in most regions, even ranging into the subtropics, that corals bleach every single year. And this is a pretty insane, pretty dire forecast for corals. Under this scenario, we've had research that shows that there's a risk that we could lose 80 or 90% of the corals in the ocean by the 2050s if the present global warming and human-forced climate change trends continue. So, and this research seems to confirm that. It's based on data by the World Resources Institute. Now, the other major effect that was covered in this paper is sea level rise. And what it looks at is what the impacts of a 2-meter sea level rise would be over that time period. And areas in blue is where we see impacts. And we can zoom in. I'm going to go ahead and zoom in on a region that's near and dear to me. I grew up in the Hampton Roads region. So we're going to zoom in and take a look at that. Now, 2 meters of sea level rise could happen by or before the end of this century. If Greenland and Antarctica really get going, we might see close to 2 meters of sea level rise in some regions by about 2050. And so what does that look like? And if you're looking at Norfolk and Virginia Beach, basically the region of Pungo is pretty much inundated. Most of the southern Hampton Roads area, including Norfolk, Chesapeake, and Virginia Beach, have basically become like a bayou where there's massive invasions of water through many regions, and the higher level regions are increasingly isolated as if they were islands. If you look at further south along the strands of barrier islands, you find that most of the barrier islands have become isolated or inundated entirely. And the same is true as we go into the Outer Banks, with Kitty Hawk primarily being some of the highlands, but if you go further down toward Hatteras Island, most of those zones are inundated or mostly inundated, as is the region of Elizabeth City, Poquoson, and the various wildlife refuges along the eastern coast of North Carolina. And this is just from 2 meters sea level rise. Long-term sea level rise from human-caused climate change, if CO2 forcing ends up hitting in the mid-500s or up to around 600 parts per million, is long-term enough to melt all the ice on Earth. So these are some ocean impacts. Check out Resource Watch. That's it for us.